So the next subsection in the textbook is free fall equations, section 3.6. Now we've already seen acceleration due to gravity. I forget if it was 3.3, 3.4. Okay. And we saw there, if you drop a ball down, that the positions every time step increases, right? The displacement increases. And so we saw acceleration due to gravity. The acceleration is actually g. Now, we saw in the previous video, in the previous few videos, we saw these equations, x final equals x initial plus v initial time plus half a t squared, and we saw v final is v initial plus acceleration times time. Now, this section shows that if you've got free fall, if you just take an object and you drop it down, and the only acceleration is due to gravity, or the acceleration is gravity, then we have these equations, okay? X final equals x initial minus half gt squared, and v final is minus gt. Now you would be very tempted to try to memorize these equations, but please do not memorize those equations. That's my advice to you. You can, I guess we can say you can memorize these guys. These are your most general equations which you should know and which we can apply to any situation. So, where do these equations come from? They come from these general equations. Okay? So, know the general equation. The other one is v final squared is v initial squared plus 2ax, or delta x. These are the general equations, which then can be applied to absolutely any situation. And the situation that we find ourselves in when we're having an object that's falling is that if it falls, what is the initial velocity? 0. So as you can see, if you want to apply this equation to free fall, then your initial velocity falls away. And then what happens with acceleration? Acceleration is actually minus g. If we take up as positive, then we've got minus g, right? Our gravity is acting down, so that's where that becomes minus g. So this gets converted into x final minus x initial equals x initial minus half gt squared. So do you see my point here, guys? Take the general equation and apply it to your specific situation. Okay? What about this second equation? We know that the initial velocity when you drop an object is equal to 0, so that falls away, and then we have minus g here. Okay, so please do not memorize them. Just use these general equations for constant acceleration, don't forget, constant acceleration, and then modify them for your specific problem. Okay? We'll do an example in the next video.